Assalamualaikum warahmatullahi wabarakatuh. Greetings there. My name is Muhammad Aminullah bin Muhammad Rashidi. I am a Form 5 student from SMKA Agama Putrajaya. In this video, I would like to show you 3 experiments that have something in common about our Petronas science competition. Well, in this video, I have provided these 3 experiments because I think that these experiments are very helpful in our daily lives. They can be very handy and can solve many problems in our daily lives, to be precise. So some people might think that these experiments are quite boring. They don't have that that awesome effect, but that doesn't really count in science. I would like to say that I think. But what I think is that these experiments are not all about those gizmos or all about those teasing stuff, all of those stunning effects that these experiments can show people. But what I can say is, in these experiments, it's all about helping others. It's all about helping people solve their problems. It's not all about seeing that it's really cool, it's amazing. It's not all about that. Like I've said before, it's all about helping others. So it's all about solving daily problems. That's what I think about these experiments, and I've included these 3 experiments to fulfill those objectives. So without further ado, let us begin and see and observe those experiments. Alright folks, in this first experiment, we have a bag of cereal. And the problem is, it doesn't really have to be a bag of cereals, but it can be a bag of like chips or snacks. So, for instance, while we are eating a bag of snacks or anything, and the problem we face is we want to just put it up, stand it up, but it often falls down. So you keep on and when you want to eat or watch a TV and then something like that, or watch movies on a laptop, and then we have the bag here. They often fall down, and then sometimes the content always falls out as well. Yeah, the content also falls out too. So how do we avoid this from happening? Well, we'll see this, we'll see that right after this, right after I clean this up. The solution to solve our problem for this bag, we're not setting up right. Well, technically it should fall down. Okay. Yep. Our problems, that kind of problem we want when we eat, while we watch our TV and stuff like that. The solution for that is we can try to fold the bottom of the bag, and thus it is able to stand properly. That's it. That's pretty much it. Like I said, it's not doesn't involve some gizmos or anything that's scintillating or mesmerizing. But it's this simple, and it is very helpful if you want to watch a TV, eat something, play video games, while you have your snacks beside you. So that's how you solve. This is the first experiment, and we shall discuss how does the science principle apply in this. And I think it has something to do with physics, which is part of science. Yeah, which is part of science, the study of phenomena. Okay, next up we have our second experiment that involves this, and this. So the scenario is we want to eat perhaps our hamburgers, French fries, or fast food with sauce. And for now we have this problem, which is we have a little bit of volume of sauce left in our bowl. And when we want to pour it down here, oh man, it takes so long for that to do so. And we often rock the bowl because of inertia, the tendency to move. And that takes kind of long for us to do that. So we shall discover the solution with this. Okay then, the solution for having the sauce pouring down into this thingamajig will be supported by hot water. And I'm going to put this ball inside the hot water. I'm just afraid that it might crack because, you know, scientifically it will crack when it has contact with hot water. I hope it don't, because we are so dependent on hot water for this experiment. And we are going to wait for a few minutes until we take the ball out. So bear with me, okay? Here goes nothing. Right. Let's wait for a few moments. Finally, ladies and gentlemen, after a lot of tries, I guess this will finally work. Come on. It's already pouring fast. Yep. There you go. Some of them is pouring out already. It's traveling really fast. You can't see it now, but it is actually pouring really fast. You can try this at home if you want, to prove it yourself. Now, our third and final experiment for this video is when we have oil being spilled into water. Now, sometimes when you're cooking, you might accidentally pour in oil into water. And as you can see, oil is less dense than water. And oil is above water. So the question is, how do we remove oil from water? And it sounds quite impossible to do so, because when you want to pour oil out, you might accidentally pour out water as well together with the oil. So the solution for this, if we want to remove oil from water, we are going to put this in the fridge and wait for the conclusion in a day. Let's check it out in 1 day time. Alright folks, here's the water in oil, and with this I'm going to remove the oil from the container through a very hard process that requires me to actually pull this out with a spoon. It's coming out. I'll show you when. Wait, let me continue this. Yeah, look at this. Got one part out. The oil. These are the blocks of oil that I've just thawed out from this. So before this we had oil up here, and then we have removed the oil from the water, and here is the conclusion. I'm going to do a bonus experiment which involves batteries and electrical appliances. What I have now is I have a functioning cassette player with dead batteries over here, and the problem is I want the cassette to work, and in order for the cassette to work I need batteries. Okay, I need batteries. So to make the cassette player work, I need working batteries, but these batteries are dead, of course. So what I'm going to do is I'm going to put these batteries up in the sun, in the open sun. And that's what I'm going to do for today, in order for these batteries to work. And I'll explain that later in the scientific slot for this. This is the cassette player that I have. It's a very old cassette player. These are the songs that I have. So I'm going to play this part of the cassette. And to prove that it actually works, I'm going to put this inside. Okay. And look at how it spins. Can you see it spins? Yes. It's a working cassette player. I'm not lying. I'm going to put the speaker closer to you so you can hear it. I'm afraid that the headphones are broken. I will get a new one after this. But to prove that it works, can you see that it's spinning? Yes, and it's moving, and it's moving with active batteries. But these ones are dead, so I'm going to replace the dead ones with these ones right after I place them in the hot sun. And I'm going to be honest in this. I'm not going to change these batteries with working ones as though they look the same. I'm going to be honest. I'm going to use the same batteries to replace the working one in the cassette player. Okay, so we'll return when after a few hours when I place the batteries up in the sun. Okay, then now we have waited for a few hours for the battery to go out in the sun. Now we're going to check out the batteries and put them into the cassette and see if it works. Okay, so let's go. Okay, from where we left off, I've taken out the working batteries and already placed the batteries up here in the sun. And now we're going to test the batteries if they work. So it feels kind of hot. Okay, it's hot. I'm going to put it into this slot here. And listen if it works. Can you hear it? I'm afraid you can't hear it, but it is spinning. It was spinning just now. See, it's spinning. It does work. Now it is proven that putting the batteries up in the sun actually works. And I will tell you why it does work and how does it actually apply here in science. The larger the area, the lower the gravitational center. The lower the gravitational center, the more stable an object. Heat is required to overcome the van der Waals forces between the molecules of the sauce. When that happens, the kinetic energy of the particles of sauce will increase as well. Therefore, the particles can move more freely. The semi-liquid solid state of the sauce is becoming more to a solid after this transfer of heat of energy. With inertia as well, shaking a ball will cause the sauce to flow. In Newton's first law, a stationary object stays stationary. An object in motion stays in motion. Once shaken, the sauce will start to stay in motion. Both water and cooking oil has a low boiling point. Hence, they are easily frozen and become solid as the kinetic energy of the molecules become dormant and stays packed together, quivering. When brought out of the fridge, the frozen oil is on top of the water. This shows that oil has a lower density than water, and we can thaw out the oil and separate them. Alright then, that is all that we have for our video, and I hope that those experiments, they may come in handy in our daily life to overcome our problems that we face. And again, thank you for watching this video, because even though those experiments, they aren't that enthralling or captivating, but I guess those experiments, they are indeed helpful